Okay. And then the other announcement is I always post the solutions to the exams on Canvas. So either later this week or early next week, I will work through the exams. I'll write down solutions and I'll get those posted so you can look over those.
Are you going to do both this time?
I will do both versions. Yeah, I think I did all the versions except for last quarter. There was 3 versions of exam 3 and I was only able to get 2 posted.
Yeah.
I will post the blank copies of the exams as well so people can reprint those and do practice. And I will also post the solutions. Okay. So we're going to go ahead and get started. So now we're kind of going to make a connection between right triangles and the unit circle. Okay. Yeah. Oh. My bad. That's what I did, is I just grabbed you one. I forgot to bring it back.
And I still need one too.
You still need one.
Thank you.
Okay. All right. Usually it's easier for me if everyone shows up on time. Okay. Otherwise, I kind of get carried away. There we go. Okay. So what we're going to be doing first is, I need my copy. We're going to find trig values of any angle. Okay, and instead of using the entire unit circle, I'm just going to use the first quadrant, angles from 0 to pi over 2. So first what I need to do is define what is called a reference angle. Okay, so let me start by drawing a picture. So here's my unit circle. Okay, remember, angles start in standard position. This is your x-axis, that's your y-axis. So start with an angle in standard position. Say I rotate so that my angle's terminal side ends up being in the third quadrant, and there's my angle theta. Okay. Now, between the angle that is formed from the x-axis and the terminal side, so this little teeny angle inside, let me grab a different color. This little angle in here is going to be called theta ref, or the reference angle. Okay, so by definition, the reference angle, theta ref, for an angle theta, is the positive angle, positive acute angle, formed by the terminal side of theta and the horizontal axis. Okay. So you draw your angle, find its terminal side, and then the angle formed by the terminal side and the horizontal axis is called the reference angle, or theta ref. Okay. So before we start using these to find values of sine, cosine, and tangent, just a couple of examples of finding reference angles. So example 1, find each of these reference angles, or find the reference angle for each of these angles. So given the angle 11 pi over 6, we're going to go ahead and find the reference angle. Okay, so you're going to, a picture always helps. So 11 pi over 6, which quadrant is that angle's terminal side going to be in? That'll be down here in the fourth. Okay. So the angle from the positive x-axis to this terminal side, that's going to be 11 pi over 6. And then pictorially, this angle here now formed by the terminal side and the horizontal axis, that is now what I'm calling theta ref, for the reference angle.
Would that be pi over 6?
Okay, and Kirsten, you said pi over 6. Okay. Now,
That's what it
one way to get it is to consider a full rotation of 2 pi, and then I would have to subtract pi over 6 to get back 11 pi over 6. Or you can think of it this way too. The reference angle plus 11 pi over 6 has to equal 2 pi. So the small angle right here has to be pi over 6. The original angle, 11 pi over 6, plus the reference angle has to equal 2 pi. So the reference angle is pi over 6. Yeah?
So, since the definition says it's a positive acute angle, it will never be negative.
That's right.
Even if it's clockwise.
Exactly. You're ignoring the sign of the angle. Okay? It's the positive angle formed by the terminal side and the horizontal axis. Okay, so that's a good question. The reference angle should always be positive valued. All right. And then you could also do this in terms of degrees. So B, what am I asking for this time? 250? So the given angle theta is 250 degrees. We'll go ahead and find the reference angle. Again, you might want to draw a picture. And it might actually help you to label some of these. Like that's 0 degrees, this is 90 degrees. This is 180 degrees, this is 270 degrees, and then all the way around would bring you back to 360. Okay, I should have maybe done that for the previous picture as well.
It's going to be in the third quadrant.
It's going to be in the
Third
third quadrant.
And the 270.
Yep, so 250, Kirsten, you said between the 180 and 270, right?
So we subtracted by 270.
So here is a picture of my 250 degree angle. It has to have its terminal side in the third quadrant. And then now my reference angle is the angle formed by the horizontal and the terminal side. So this in here is going to be the reference angle. Okay. And what do I have to find the difference of this time? Well,
250.
so it'd be 250, but I'd have to subtract off the 180 degrees. Okay, so how do I get to 250? You first go 180, and then I'd have to add 70 more degrees. Or if you like, you can write it this way. Theta ref is the full 250 degrees minus the 180 degrees, and you end up getting 70 degrees. Yeah.
And it'll always be in reference to the horizontal axis.
Yeah.
Okay.
Yep. It's always the angle formed by the horizontal axis and the terminal side of the given angle.
Okay.
Good so far? Chris?
What if it's 270? Which?
So if it was 270, let's see. Yeah, if that
that's
was
the
my
next-
terminal side, it would just, my reference angle would just be 90 degrees.
Because it's the same either way.
Okay.
Yeah, it's the same either way. So this, the horizontal and 270 would leave you with a 90 degree angle on the in either of those quadrants. Yeah,
At the
Brandon?
moment that goes to 271 degrees, the theta reference becomes, let's see, 360? Or not 360, it just, you have to use the right side of the horizontal instead of the left.
Yep,
Okay.
exactly. Let me entertain that for everyone because that's a good question. So, Brandon's question was, what if we actually did like a 271 degree angle? Oops. So that's 271 degrees. Okay. What you would do is your reference angle would be this angle right here. Like you said, it would have to be with the positive side of the horizontal. And in this case, theta ref would just be a full rotation, and then you would subtract the 271. Okay? There is no formula. Draw the picture. Okay? There's no formula that works every time. And I'm not going to do this. If theta's in the first quadrant, this is the reference angle. If it's in the second quadrant, this is the reference angle. Just make sure to draw your picture and just reason through to figure out what you need to do to find the reference angle. I mean, I guess it's true if your angle's in the fourth quadrant, it's always going to be a full rotation minus the given angle. If you're in the first quadrant, the angle itself and the reference angle are the same. Okay, up to sine. Okay. So if you have a positive angle in the first quadrant, it's going to be the same as the reference angle. Now let's do a -1. And again, I'll keep my sine, cosine, tangent values up there. Okay, so what if now the angle theta is -3 pi/4? Again, draw yourself a picture and determine which quadrant this is in. So -3 pi/4 is almost half of a clockwise rotation. It's going to land you starting from the positive or the standard position. You're going to probably end up in the third quadrant. Okay, because it's just slightly more than minus pi.
Could you also add 2 pi to that to get a coterminal angle, or would that give you a different answer?
I guess you could add 2 pi to this to get a coterminal angle. That would just be giving you probably this angle right here. I would probably just draw the picture and reason it out. Because if this is, I guess, if this is pi, and you went -3 pi/4 or 3 pi/4 in the clockwise direction, how much further would I have to go to get up to the horizontal? You'd have to go another pi/4 units. So in this case, the reference angle is just going to be pi/4. Again, here's your little reference angle right there.
If you add 2 pi to it, or anything to get any other coterminal angles, the reference angle will always be pi/4 though, right?
Yes.
So if you had like
So
some ridiculously huge number, it would still just be pi/4.
yeah, as long as it's coterminal with the given angle. So yeah, Maddie, you made a good point. Any two coterminal angles will have the same reference angle. So I could have added 2 pi to this first. That would have given you 5 pi/4. So I guess we can entertain that as well. So say I did that as well. Theta equals -3 pi/4 is coterminal with 5 pi/4. If you add 8 pi/4 to this, you get 5 pi/4. And then that angle would be displayed up here. And then if half a rotation is pi and you went 5 pi/4 to get to the terminal angle, it'd be the same. Theta ref would be the same. It would still be pi/4. In that case, you could just do 5 pi/4 minus pi, if you like. And that would give you your pi/4. So there's more than one way of thinking of this. And I'm not going to choose for you. You need to get in there and do the practice, draw the pictures, make sense of it on your own. And then generally you'll find what way works for you the best. Everybody okay with the definition? Reference angle is always the positive angle formed by the terminal side and the horizontal axis. Okay? So your reference angle is always positive. Now we're going to use reference angles to find values of sine, cosine, or tangent. Instead of using the entire unit circle, we can just use the first quadrant of the unit circle. Okay. I personally like this way better. Like, I hate having to memorize what the memorize what the points on the unit circle are for a given angle. I prefer to use less information. Okay, so just only having to memorize the first quadrant and using reference angles, I like better than having to memorize the whole unit circle. So, let me give you the formulas here. So, trig values of any angle. So the second box at the bottom. Okay, so sine of an angle theta, cosine of an angle theta, and tangent of an angle theta, there's two possibilities. And you're going to be able to rewrite these in terms of sine of the reference angle. So let's look at a picture. Okay. So here's my unit circle. Let's deal with sine first. I have a better blue than that. I'll go with this one. So for simplicity's sake, I guess I'm just going to assume, I guess it doesn't really matter where I assume it. I'll just say my angle theta lands me into the second quadrant. And then right here in the picture, this would be my reference angle right here. Okay. And also, the reference angle can be seen over here if you think of a reflection. So there's the reference angle just redrawn in the first quadrant because it's a positive angle. Okay. Now, what's true about the y-coordinates of both of these points? They're the same, right? So in this case, if your angle's anywhere in the first or second quadrant, what ends up happening here is that sine theta, which is the y-coordinate of this point, ends up being the same as the y-coordinate over here, which is sine of the reference angle. I don't care what the x-coordinate is. I guess it's cosine theta and cosine theta ref. Okay. So in this case, sine of theta equals sine of the reference angle if the angle is between 0 and pi. So this will just be sine theta ref if you're in the first or second quadrant. Anybody have a guess as to what's going to happen if you're in the third or fourth quadrant? Huh? The same, except for there will be a negative sign. I'll draw the picture in a second. And actually, instead of saying this, I'm just going to draw a picture. If you look in the book, it's just saying sine of theta is going to be sine of the reference angle if your angle's in the first or second quadrant. It doesn't have to just be between 0 and pi. Okay. And then let's go ahead and look at the picture in the other case. So if your angle, let's say it's in the third quadrant this time. Right down here, this is my reference angle. Okay. And then I'm going to take that angle and I'm going to again just draw it in the first quadrant. So here's another copy of the reference angle just redrawn in the first quadrant. So up here, on the unit circle, if you do a rotation by an angle, by the reference angle, the y-coordinate is sine of the reference angle. Down here, the coordinates of this point are sine theta and cosine theta. Now, notice sine theta is, if we're in the third quadrant, what kind of a value is it going to be, positive or negative? It's going to be negative, but sine of the reference angle is actually going to be positive. The only difference is they're just going to differ in sign. So in this case, sine of theta is just going to be minus sine of the reference angle. I got to redraw my picture here. I got to draw smaller pictures.
Could you also write the other way? The pi greater than or less than equal to 0?
Well, what if my angle, though, what if theta is
So
25
that's
pi
just
over 6?
Wrong. I shouldn't have write it down at all.
Yeah, I should not have written between 0 and pi. It's better and more complete to say if the angle lands in the first or second quadrant. Okay, rather than try and give a range of values. There's infinitely many angles that would land you in the first or second quadrant. Okay. So sine of theta is going to be sine of the reference angle if your angle has terminal side in the first or second quadrant, and it's going to be minus sine of the reference angle if you're in the third or fourth quadrant. Now, why is this useful? The reference angle is always going to be between 0 and 90 degrees, or 0 and pi over 2. So once I have this table of values memorized, I don't have to think about all the points on the unit circle anymore. I can just think of the coordinates between 0 and pi over 2 and just exploit the reference angle. Now, cosine and tangent are going to be the same. I just have to tell you which quadrants they're in. So, anybody have a guess? Cosine of theta is going to be cosine of the reference angle. Which quadrants is cosine positive in?
1 and 4.
1 and 4. Okay, so this picture now becomes, if your given angle is either in the first quadrant or the fourth quadrant. And then which quadrants is cosine of an angle negative?
2 and 3.
Quadrants 2 and 3. And then finally, for tangent, anybody remember which quadrants tangent is positive in?
1 and
Well,
4.
hold on. Let me let some people catch up. Probably going a little quick. I'll do it slightly differently this time, though. Instead of using the unit circle, I'm going to use the graph of tangent. Just a different approach. Okay. So tangent of theta is going to be tangent of the reference angle. Wherever tangent is, wherever theta is going to give you a positive value of tangent. Looking at the graph of tangent theta is positive for angles, well, I guess I could have done one more over. So minus pi over 2 to pi over 2, that's in the first or fourth quadrant. Think of your unit circle. So this is minus pi over 2, that's 0, this is pi over 2. So if you're in either of those two quadrants, tangent is going to be positive. Is that right?
No, that's not right. It should be 1 and 3.
Oh, oops. Sorry, we're negative over here.
Yeah. No, it should be 1 and 3 quadrants.
Okay, that was just a test.
Okay.
Okay, so sorry, between 0 and pi over 2, that's the first quadrant. And from pi to 3 pi over 2, tangent is positive. So sorry, tangent of an angle theta will be tangent of the reference angle wherever tangent is positive. So what I should have here is my little picture if I'm either in the first or the third quadrant. Okay, and then it's going to be minus tangent of the reference angle if you're in the second or fourth. Again, you can see that from the graph. 3 pi over 2 to 2 pi, that's the fourth quadrant. Pi over 2 to pi is going to give you the second quadrant. So now we don't have to memorize the entire unit circle anymore. So let's see how this works with some examples. So if you want to do sine, cosine, or tangent for an angle, it comes down to identifying the reference angle and then either throwing a plus or minus out front. So let's find sine, cosine, and tangent for the following angles. So A, we're going to do theta equals 240 degrees. Okay, so first thing we should do is find the reference angle. Okay, so draw yourself a picture. That's 0 degrees, 90 degrees, 180 degrees, 270 degrees. So 240 degrees is going to land us in quadrant 3. Here's our reference angle. And this was our 240 degree angle. So what am I going to get for a reference angle this time? Yeah, if going half the way around the unit circle is 180 and we went 240, the distance in here ought to be 60 degrees. Or if you like, theta ref is the full rotation of 240 minus the half rotation of 180, and you'll get 60 degrees. Okay, so sine is either plus or minus sine of the reference angle. And then what am I going to choose for a sine? If we're in the third quadrant, sine has a negative value. So that'll just be minus sine of the reference angle. And then I always have to remember which one of these is 30 and 60. Well, pi over 6 is the smaller of the two. So that's really 30 degrees. Pi over 4 is 45. Pi over 3 is really 60 degrees. And then pi over 2 is 90 degrees. And what do we know? Sine of 60 degrees is root 3 over 2. So this is just minus root 3 over 2. Okay, what about cosine? In the third quadrant, is cosine positive or negative? We're to the left of the vertical axis, cosine is an x-coordinate. Cosine is going to, again, be, since cosine of 240 is a negative value, it's going to be minus cosine of the reference angle. So minus cos 60. And cosine of 60 degrees, or pi over 3, is 1/2. So this just equals minus 1/2. Now, do I really need to use a reference angle for tangent? Why not? Okay, yeah, if you already know sine and cosine, tangent of 240 is going to be sine 240 over cos 240. Okay, which is going to be minus root 3 over 2 divided by negative 1/2. We'll end up getting root 3. So sorry, I skipped the arithmetic there. You could also, what's that?
It's also in the table.
Yeah, because you could also say it this way, tangent is positive in the third quadrant. So tangent 240 is just the same as tangent of the reference angle 60 degrees, which Maddie, you said was in the table, it's root 3. So go ahead and try the 11 pi over 6. I should have maybe done something more interesting, like something that wasn't already on the unit circle, but go ahead and do that with reference angles for a couple minutes. What was that? I hear donuts.
That's how I heard.
I
Big
just-
donuts.
There's something to be wrong about.
I need to not eat donuts.
I thought I heard something strange.
Let alone big ones. Hopefully you didn't mean something inappropriate or something. I don't know.
We'll survive.
I don't know.
We're adults.
That's true. So what'd y'all get for a reference angle? Okay, I think we did this already in the example 1. 11 pi over 6 gives you an angle of pi over 6 with the horizontal on the terminal side. Okay. Now, what quadrant is 11 pi over 6 in? Okay, so we're in this case where our angle's in the 4th quadrant. So let's see, what does it say? If your angle's in the 3rd or 4th quadrant, sine of an angle is minus sine of the reference angle. So you get minus sine of the reference angle pi over 6, and sine of pi over 6 is 1/2. What about for cosine 11 pi over 6? Anybody mad yet that I made you do the unit circle first? A little bit? You can get mad at the textbook. I just chose that order, but... so cosine of 11 pi over 6 is either plus or minus cosine of the reference angle. What's the sign going to be out front? Positive. If we're in the 4th quadrant, x coordinates are positive. And cosine pi over 6, looking at your table, is root 3 over 2. Okay. And then you can do the same with tangent if you want. In the 4th quadrant, tangent is going to be negative. So you get minus tangent of the reference angle. And what does our table say? At pi over 6, tangent is 1 over root 3. Which is also the same thing you'd get if you did sine over cosine.
Is it okay if we do the root 3 over 3?
Yeah, if you want.
I don't know.
I'll show everybody how you get that. You can rationalize the denominator by multiplying that back fraction by root 3 over root 3, which will leave you with minus root 3 over 3. 1 times root 3 is root 3. Root 3 times root 3 is positive 3. Yeah, I don't care if you give me the one with the radical in the denominator, or if you like to rationalize, that's fine. If you like the rationalized version, that's
It depends on my mood.
Depends on your mood. Me too sometimes. Is it okay if I give everyone maybe something that's outside of 0 and 2 pi real quick for practice one more time? Okay. So if you like, you can call this part C. So let's say the angle theta is 19 pi over 3. You'll have to think a little bit harder about this one. So for now, just try and find the reference angle. And I'll show you a trick, maybe. Anybody have any ideas for how to find the reference angle?
subtract 2 pi until you get between 0
Ah. Okay. So rather than trying to think about how many rotations this is and where you land, that'd be one way to do it. Which actually that's what I was going to do. But I like the coterminal angle method as well. Because sine, cosine, and tangent are all the same for any coterminal angle. So theta equals 19 pi over 3 is coterminal with, and I'll just start writing them down. So you can subtract 2 pi, 6 pi over 3 once, and I think you'd get 13 pi over 3. And what would the next one be if you subtract, and that's still not between 0 and 2 pi. So subtract another 6 pi over 3, I'd get 7 pi thirds. That is still a little bit bigger than 2 pi. So if I subtract 2 pi one more time, I just get pi over 3. Well, that wasn't actually all that interesting this time. Okay. So sine of 19 pi thirds was the same as sine of pi thirds. But that's already one of my special angles in the first quadrant. I should have maybe done something like 21 pi thirds or something like that. Okay. I could have chose a different angle that landed me in either the second, third, or fourth quadrant. So this time we're using coterminal angles, and sine of pi over 3 is just root 3 over 2. Cosine of 19 pi thirds, which is the same as cosine pi thirds, is 1/2. And tangent 19 pi thirds is just sine over cosine, or it's the same as tangent pi over 3, which is just root 3. So my suggestion is, if you're ever given an angle that's not between 0 and 2 pi, I would find a coterminal angle in 0 to 2 pi before you find the reference angle. Okay. So that was a good suggestion, Ben. So always first find a coterminal angle between 0 and 2 pi, then you can find your reference angle. Since you're coterminal with pi thirds, the reference angle is pi thirds, so there's not really anything interesting going on in terms of reference angles. What are we sitting at?
We've got 4 minutes left.
Okay, let me do one thing real quick. Let me at least get these supplemental angle identities taken care of here. Is it okay if I erase this here? Alright, so supplementary, and did I write angle? Yes, I did. So the tangent supplementary angle identity, basically supplementary angles are just angles that differ by a multiple of pi. So theta and 180 plus pi or 180 minus theta or any of those are called supplementary angles. This one we're going to do together in example 3, but we can draw a picture of the unit circle to find these top two. So I'm just going to simplify this and assume the given angle theta is in the first quadrant. So here's a picture. If I assume my first angle theta is in the first quadrant, anybody tell me where 180 minus theta is going to land?
Between pi.
So that'll be between
0 and
So if I go all the way 180 degrees and subtract theta, that's going to leave me right here. So here's 180 degrees minus theta. And what does it look like is going to be true about the y-coordinates of both those points? The same. So sine of theta is the same as sine of 180 minus theta. So it's true that sine of 180 minus theta is sine of theta. Okay. And then I'd have to draw a new picture for cosine. Actually, no, I don't. It's already up here, right? The coordinates of this point are cosine theta, sine theta. And the coordinates over here are cosine 180 minus theta and sine 180 minus theta. So for a given angle, the x and y coordinates are just sine or cosine or sine of that angle. Now what's going to be the only difference between cosine of theta and cosine 180 minus
It's
theta?
gonna be negative cosine.
Yeah, yeah. So if I drew this in the first quadrant, if I reflect, it'll make, like Reed said, the x coordinate negative, so this is just minus cosine of theta.
And that tangent will be negative because cosine's negative.
Yep. Tangent would be negative. I guess basically we can do example 3.
We got no time though.
Are we
Yeah,
fully
we're
out?
10:20 right
All right.
now.
We'll write this one down tomorrow, but it's just we'll work through it tomorrow real quick. So we've got the first two, and then we'll do the other one tomorrow. And then I'll go downstairs and get the homework open ASAP right now.
Interesting day.
Brittany.
The mystery's over, about a test.
It's really on 53 here when I said that. 53.